The early 80s weren't about moon landings or Mars colonies, not yet. But make no mistake, 1982 and 1983 were foundational. These were the years when the Space Shuttle grew from an experimental promise to a symbol of routine space access, and NASA quietly laid the groundwork for the missions that would define the decades ahead. Let's start in March 1982 with STS-3. Astronauts Jack Lousma and Gordon Fullerton launched aboard Columbia for an 8-day orbital mission. The focus? Thermal testing. They flew the shuttle nose first into the sun, then flipped tail first, exposing Columbia to extreme temperatures in space. But when it came time to land, trouble, right here on Earth. Edwards Air Force Base was soaked by rare desert rain, so Columbia had to divert to White Sands, New Mexico. The landing was safe, but that soft gypsum dust. It infiltrated the brakes, tires, and avionics. It was a nightmare to clean. Lousma later described the landing like skipping a rock across water. Columbia, he said, was a flying brick. 3 months later, STS-4 lifted off in June, the final test flight. Astronauts Ken Mattingly and Hank Hartsfield were on board. Their mission included a classified Department of Defense payload, or so it seemed. Here's the twist. Part of that classified cargo? Totally empty. It was a decoy used for satellite handling drills during the Cold War. When the crew returned to Earth, President Ronald Reagan greeted them on the runway, the first sitting president to do so. He declared the shuttle fully operational. But insiders knew the truth. Operational? Maybe. Perfect? Not even close. "1983 was a breakout year for shuttle missions, new orbiters, historic firsts, and a new kind of astronaut. In April, Challenger flew her first mission, STS-6 on board, TDRS-1, NASA's new communications satellite. But things went sideways. A malfunctioning booster left the satellite in the wrong orbit. Engineers spent months recovering it. Eventually, it worked barely. Here's something most people don't know. Challenger wasn't meant to fly. She was built as a structural test article. But when Columbia ran into heat and weight issues, Challenger got upgraded and took flight. STS-6 also featured NASA's first shuttle-era spacewalk. Story Musgrave and Don Peterson tested new suits and tools outside the spacecraft, setting the stage for future repair missions. Then came STS-7 in June, and with it Sally Ride, the first American woman in space. She operated the robotic arm, deployed satellites, and calmly made history. But off-camera, the press was absurd. Will zero-G affect your reproductive organs? Do you plan to wear makeup in orbit? Before launch, NASA handed her 100 tampons. For a 6-day mission, they asked, will that be enough? Ride just laughed. You can cut that in half. August 1983, STS-8, a night launch. A night landing. A first. But more importantly, Guion Bluford became the first African-American in space. He wasn't just a token pick. Bluford was a decorated Air Force pilot, an aerospace engineer with over 5,000 hours in the air. During training, he crushed a high-G simulator that had left others sick. He joked, "You guys just don't have the right playlist." Finally, STS-9, November 1983, Spacelab's debut. This European-built science lab turned the shuttle into a flying research center. Ulf Merbold, the first West German astronaut, joined the crew. Over 70 experiments were run in orbit, in life sciences, materials, fluid physics, and more. Conditions were so cramped that astronauts improvised with binder clips, Velcro, and socks. While the shuttle soared, NASA's robotic explorers kept going. Voyager 1 and 2 were still transmitting. Voyager 2 had just crossed beyond Saturn, slowly closing in on Uranus. NASA's Earth Science Division made waves too. Landsat 4 was giving scientists a clearer view of the planet than ever before. Forests, farms, floods, all tracked from orbit. And Nimbus 7, quietly collecting ozone data that would later reveal a hole in the atmosphere. Some of the most important missions of this era didn't launch at all. The Hubble Space Telescope, once promised for the early 80s, was stuck. Budget issues, technical delays, missed shuttle windows. By 1983, Hubble's primary mirror was complete, but it had a flaw no one had caught yet, a spherical aberration that would later cripple its vision. Still, NASA pushed on. Europe partnered with the Faint Object Camera. The scientific world waited. Hubble was coming someday. Next up, Galileo, NASA's long-awaited mission to Jupiter. Packed with instruments, it was ready for launch. But NASA canceled the hydrogen-fueled Centaur upper stage. Too dangerous for the shuttle. Galileo was grounded, delayed, rewritten. One engineer called it the mission to nowhere. It wouldn't fly until 1989, and only after a long, winding route through the inner solar system. At the Lewis Research Center in Ohio, engineers were working on something radical: solar electric propulsion. Instead of fuel, electricity. Instead of fire, ions. One prototype, the junction effect thruster, could run for thousands of hours. NASA envisioned space tugs powered by sunlight, ferrying satellites from shuttle to orbit. Too early for its time, but the idea would return decades later. (1982 and 1983) weren't about giant leaps. They were about critical, careful steps forward. Shuttles flying, diverse astronauts breaking barriers, Earth science growing, deep space missions in the oven, new propulsion, born in labs, waiting for their moment. Quiet years, maybe. But make no mistake, the ripples from these 2 years are still moving outward. If you enjoyed this narrative, make sure to like this video and subscribe to our channel at Beyond Earth Buckle Up for more fascinating NASA history narratives. Remember to take care of one another and always keep looking up.